Moving on, we will now shift our attention to the working principle of access control and delve into how it functions. We are familiar with the process of opening a door using a card. The individual swipes their card at the entrance and the door unlocks. It's quick and effortless, but we will need to consider 4 essential questions during this process to grasp the fundamental workings of access control. We must understand how cards are read, and how their information is transmitted, and how permission is authenticated, and how doors are unlocked. The first question is how a card reader accesses and obtains the information from a card. We know that when the card is brought near the reader, its data can be acquired. However, the question remains how. The answer lies in RFID technology, an acronym of radio frequency identification. There are 2 types of RFID tags, passive and active. Passive RFID tags receive power from the reading antenna found in the card reader, which induces a current in the RFID tag's antenna. ID and IC cards are typical examples of passive RFID tags. An active RFID tag has its own power source, often a battery, for example ETC. Active RFID tags have a longer read range than passive RFID tags due to the stronger power source. The frequency of the RFID is another determining factor that affects the reading distance. There are 3 types of RFID cards, categorized by their frequencies. Low frequency at 125 kHz RFID card with a reading distance of 1 to 2 cm. The common models include ID, typically EM card, HID proximity card, and high frequency at 30.56 MHz RFID card with a reading distance of up to 10 cm. The typical HR cards include IC, typically M1 card, DASFile, and HID I-class card. Ultra-high frequency at 860 to 960 MHz RFID card with a reading distance of 1 to 20 meters. ETC, electronic toll collection, is a common UHF card. Okay, now we know the card information is transmitted by RFID technology, and it can be categorized into active and passive tags and different frequency cards. The second question is how to transmit card information from card reader to controller. There are several options available to transmit data between a card reader and controller in an access control system, including WAGON, OSDP, RS485, and TCP/IP protocols. Let us now compare these 4 protocols based on different factors. WAGON and RS485 are commonly used in access control systems. RS485 supports a transmission distance of up to 1,200 meters, allowing the card reader to be situated far from the controller. However, the design of WAGON system needs to consider distance limitations, as it is limited to 150 meters. The transmission mode defines the direction of signal flow between 2 connected devices. WAGON operates in simplex mode, and while RS485 uses half-duplex communication. What do simplex and half-duplex transmission modes mean? The data transmission between the controller and the card reader can be done using simplex, half-duplex, and full-duplex mode. With simplex mode, the transmission is one-way, and the card reader can send person ID or card number or credential model like fingerprint model to controller to check permission and decide whether to open the door or not. On the other hand, half-duplex and full-duplex modes support two-way communications, enabling the controller to send device status, detect signal, and person information to the reader, such as credential and ID card number. This means that a controller can identify a more functioning device and manage LED indication. In addition, fingerprint and face recognition readers knows the credential models belongs to which specific person, and fingerprint and face recognition readers can send person ID to the controller, which is faster than transmitting the face or fingerprint model. The primary difference between half-duplex and full-duplex is the half-duplex transmission involves two-way communication, but the connected devices interchangeably use the channel, and full-duplex transmission involves simultaneous two-way communication. By supporting customized encryption, the RS-485 interface enables secure connections that are superior to those supported by Wigan. Due to its standard protocol, Wigan is a popular choice for connecting devices from different brands, as it enables controllers and readers from varying brands to communicate with each other via the Wigan protocol. Unlike Wigan, the RS-485 interface can be customized by different brands, limiting its ability to support connections between devices from a single brand. And RS-485 offers faster transmission speed than Wigan, but in terms of cost, it is more expensive compared to Wigan. The maximum number of devices that can be linked to an RS-485 LAN is 32, while only one device can be linked via a Wigan LAN. This means that if multiple Wigan readers need to connect to a controller, they will use up multiple Wigan protocols on the controller one by one. In contrast, with RS-485 connection up to 32 readers can connect to one RS-485 interface. In summary, the RS-485 protocol outperforms Wigan in terms of allowed distance, transmission mode, security level, and transmission speed. However, if you need to link a controller and reader from different brands, Wigan protocol is necessary for transmission, and it is more cost-effective than RS-485. In addition to Wigan and RS-485 protocols, the access control system widely employs OSDP and TCP/IP protocols for communication. OSDP uses RS-485 as underlying communication protocol. Therefore, you see the performance of OSDP is quite similar as RS-485. But OSDP supports high-end AES 128 encryption, an open standard for customization. Moreover, it comes at a lower cost than RS-485. And TCP/IP protocol is newly used in the access control system. It means access control uses the Internet and the Internet protocol to verify credentials. There is no limitation of allowed distance, and many access control systems can even function wirelessly. Additionally, full duplex communications enable two-way transmission simultaneously within an IP access control system. Because IP-based access control systems use the Internet to carry data instead of wires, they have the bandwidth for more complex data at 1000 Mbps and features like video feeds. To transmit card information between the reader and the controller, a transmission protocol is employed. Different protocols have unique features and performance capabilities, needing careful selection of the appropriate protocol for a given access control system. Alright, let's wrap up our discussion on transmission mode by answering two questions. The first one is, what is the transmission mode of Wiegand protocol? The answer is simplex transmission, which means the card information only can be transmitted from reader to controller, but not from controller to reader by Wiegand protocol. The second one is how many devices can be connected on our RS-485 LAN at most. You can connect up to 32 devices on our RS-485 LAN. Moving on to the next subject, we will examine how a person's permission is identified. Our discussion will center on the complete process of authorization identification, beginning with the administrator configuring permissions on management software. This includes adding a person's credential information such as passwords, card numbers, face pictures, fingerprint models, and editing permissions for individuals. For instance, employees may be granted access to all doors within an office on weekdays, but not on weekends. Subsequently, the software transmits this information to the control unit, which comprises two types, a control panel or a standalone terminal. Both of these units will save the authorization data, ensuring that they can function properly even if offline. The control panel is linked with readers that employ facial recognition, card scanning, or fingerprint identification technology. When an individual presents their credential to the reader, it is identified and transmitted to the control panel. Then, the control panel verifies the request by comparing the provided credential with the permission details received from the software. If the credentials do not match those on the list, the door remains locked. And if the credentials match, the control panel sends a signal to the door relay and unlocks the door. The same applies to standalone terminals, which merge the functions of both controllers and readers. Consequently, they can scan credentials, verify authorization, and manage door control. The final question is how to open door. Two types of circuits exist for door control, normally closed and normally open. These terms are not limited to access control, but are employed extensively in the domains of electrical components, electronics, and engineering. In normally closed circuit, the circuit is closed in normal situation, and the magnetic lock is powered so the door is locked under the magnet's attraction. If someone presents the credential and successfully passes authentication, the controller sends an unlocking signal and causing the circuit to open, thereby allowing the door to open due to the absence of magnet's attraction. And in contrast, an open circuit is typically in an open state when it is not activated. However, after a person's authentication is verified, the circuit closes and the door unlocks. It is important to note that locks used in these two types of circuits are different. And in addition to the reader, there are two special devices can be employed in access control system. They are exit button and fire emergency brake. Exit buttons are suitable for use in electronic locking solution, which needs to provide a free access option on the door. The exit button is connected to the access control unit, which controls the locking mechanism of the door and using valves. An individual that needs to exit the building or pass through the door simply has to push or press the button. The exit button sends a signal to controller to open the door. And the fire emergency brake is a vital component that helps quick evacuation during fail detection or any other emergency situation while the operation of access control system needs to be disabled. It can be used for open or closed circuits. This emergency brake glass switch cards the circuit immediately and opens when the glass is pressed hard and broken. And this diagram shows us the connection of emergency brake in the normal closed circuit. If it is in the normal open circuit, the connection will be a little different. Alright, we now finish all the content in the course and let us make a conclusion. In this Fundamental Access Control System course, we firstly focus on the definition of access control, and it can be defined with 3 keywords. They are who, when, and where. Then we learned the access control system developed from keys to keypad to card to biometric and mobile credentials. In the final part, we discuss the working principle of each steps during access control one by one, from read card to transmit card information to identity, permissions, and open door. Okay, thank you for your listening and look forward for our next meeting.